Start broadcast.
The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, everyone, and welcome to today's webinar, IIoT, bringing OT and IT together. Very pleased that you could all join us here today. My name is Don Pearson. I serve as our Chief Strategy Officer here at Inductive Automation, and I'll be the moderator for today's webinar. I think we have some great panelists who I will introduce in just a few minutes to really facilitate our discussion. On the agenda, we'll start by briefly introducing our company and the Ignition Industrial Application Platform. Then we'll talk about OT-IT convergence, implementing IoT from the ground up, the new Ignition IoT solution, and the MQTT protocol. And as we always do, we'll end with the Q&A, so please type in your questions and we'll answer as many as we can. If we don't get to all your questions, of course, we always do follow up afterwards and make sure they get answered. Just as a comment on the agenda, you know, it's interesting, today's webinar is a little bit of a follow-up from what we did last month when we introduced the CirrusLink Solutions modules, MQTT for Ignition. And a lot of interest from many of you to sort of step back a little bit and take a look at what's going on in the industry and where things are going and what the trends are, and maybe put Ignition and MQTT in the context of some of these broader trends. And so that's what we're going to be doing today. Please feel free to go anywhere you want with the questions, and we will we'll cover as much ground as we possibly can with the time we have. Just a little bit of background on Inductive Automation. We were founded in 2003. That means 13 years in the industry for us, and really, and since day one, we've been an independent company with no outside investors. Company's been growing at an extremely rapid rate. We're very pleased with the response that our software has gotten from industrial organizations around the world. We serve, obviously, HMI, SCADA, and MES needs of enterprises now in over 90 countries. We got over 1,400 integrators working with Ignition across those countries. If you want more in-depth information on us or anything about our company, just go to our website and go to the About Us section, and I think we cover quite a bit about our organization, our management, our background, and things at that location. Ignition actually it's trusted by thousands of companies, including 40 of the Fortune 100 companies. Been used virtually in every industry, from you name it, oil and gas, water and wastewater, food and beverage, government, transportation, packaging, and honestly, the list just goes on and on. It's a platform that has the capability of serving just about any industry need you can imagine. There's a lot of reasons for that. I'm just going to name 6. Ignition, really, it's the first database-centric, cross-platform, web-deployed industrial application platform that's perfectly used for HMI, SCADA, and IoT. It's often used for SCADA, no doubt, but it's really totally unique from what are considered traditional SCADA solutions. It's SCADA and, as we say, a whole lot more. It's web-based deployment, unlimited licensing, lets you have as many tags, clients, connections, devices, concurrent designers as you want, which really opens up the capability for innovation with the platform, offers security and stability. It's easily expandable because of the modular architecture, and really facilitates rapid development and deployment and real-time control and monitoring. So there's a lot of strengths, I think, that those of you who are familiar with the platform understand. If you're not, of course, you can become familiar by downloading and take a look at it yourself. Now to introduce our panelists. Arlen Nipper is president of CirrusLink Solutions. Arlen has 37 plus years of SCADA experience, including designing and manufacture of complete SCADA system infrastructure implementations for Fortune 100 oil and gas companies. He's co-inventor of Message Queuing Telemetry Transport, MQTT. This is a SCADA message transport that he created in conjunction with IBM. So Arlen, that's a brief introduction from me, but I'd like you to take a little bit more time and tell us about yourself and CirrusLink.
Thanks, Don. As you said, with 37 years in the industry, I may not know a lot, but I've been around a long time. Really, CirrusLink came about, we've been around for about 4 years. We are privately owned and doing quite well. It was the outcome of my experience in the both embedded computer industry and then applying these embedded computer boxes to solutions in the field. Having worked with IBM and having been able to use MQTT for the last 17 years, and that's one thing I want to point out is that although MQTT seemingly has emerged just here recently as a quote Internet of Things transport, it's actually been around in the SCADA industry for the last 17 years. But I felt like there was space in the industry for a company like CirrusLink to come in and provide the enablement and the solutions for where I believe MQTT can really go. So that is what CirrusLink puts together, and over the course of this, we were very fortunate in finally finding a platform that actually leveraged all the advantages of MQTT, i.e. Ignition.
Thanks, Arlen, and Emily, thanks for taking time to join us here today. Travis Cox is Co-Director of Sales Engineering and Inductive Automation. He's also here to assist and partake in our discussion today. Travis, could you tell us a little bit about yourself and your background here at Inductive Automation?
Yeah, thanks, Don. So as Don said, I'm the Co-Director of Sales Engineering. I've actually been with the company since the beginning, since 2003, so I'm going on my 13th year. So I've had a part of developing the software. I've trained over thousands of people on Ignition. I've done numerous projects in helping customers with Ignition, so I'm an expert there. Currently in sales engineering, our division is the solutions division. Basically, we're the technical people that offer architecture discussions and knowledge about the product with end users and integrators. So I'm here today to answer any technical questions that we may have.
Great, thanks. And I'm pleased that having both Arlen and Travis here, we've got, I think, deep expertise both in MQTT, as you can tell from Arlen's introduction, and in the Ignition platform and the role that both play in IIoT solutions from Travis's background. Today we're going to be discussing the convergence that's unfolding between OT and IT. It wasn't that long ago there was a clear divide between OT and IT, but really all of that has changed. And I think it's important to understand why this change is happening and to talk a little bit about the best way to navigate through it for you as integrators working with your customers or as industrial organizations within your the challenges you face in automation and enterprise deployments. So it really has been for decades that the OT and IT were seen as two distinct technology areas, and they were developed and maintained and supported pretty much separately. IT encompassed a whole range of technologies for information processing, including software, hardware, communications technologies, and related services. And in general, IT was used to generate data for the enterprise or facilitate communication in some way within the enterprise. It's been primarily used as the management level, and it is based as sort of top of the organization and extends down into some areas in a more of a top-down way, centralized in the organization. IT personnel are very adept at all of these modern communications technologies. They understand SQL, Java, and all the IT technologies that they deal with on a regular basis. By a little bit of comparison, OT has really been for the machinery and the other physical equipment, for monitoring and control systems such as SCADA. Operational technologies developed, implemented, supported separately from IT, sort of in an independent world of their own. OT is built ground up from the plant floor, from the field up. So OT and controls personnel they're very adept with technologies like the PLCs, the HMI SCADA, and all those plant floor field knowledge skill sets. So just with that quick context there, maybe I'll start with you, Travis, then go to Arlen. What are your general thoughts on all the experience you've had with the projects you've done on the different environments or cultures you run into with OT and IT, and this evolution we're talking about and how the two groups view each other? Travis?
Yeah, so I mean, this, OT and IT, the riff, if you will, has been there for a long time. And I think it's really because on the operations side, you have things that are typically proprietary, things that you have to have a real deep knowledge of, especially with how they work. That includes PLCs and, of course, SCADA systems as well. On the IT side, you have things that are more open, more standards-based, and things that are more open source that they're using as well. And so with that, they're just completely two different worlds. And the operations world, well, it has to be very, it's high risk, has to be secured, has to be typically isolated because you don't want things accessing, your machinery on the plant floor. And on the IT side, a lot of their systems are in the cloud, so things are just more secured through normal means there. So I think it's just been that IT clearly doesn't really understand all of the things that OT has, and vice versa. OT doesn't really leverage some of the things that IT has. So I think as we talk here today, really the convergence of OT and IT, really there's a lot of benefits around that, and we'll see a lot of those here.
That's great. I think that really puts it in good context. Arlen, you've been dealing with this, even talking about your experience, obviously tons of field experience, but you've also dealt with folks in the IT level over the last 17 years, certainly, and maybe longer. Your comments in this OT IT world?
Well, again, it's everything that Travis said. Plus, I think with OT, at this up until now, you couldn't move as fast. I just got off a project here the last few months, and we did due diligence, and we're finding, Modicon 484 PLCs that were installed in 1978. So, IT, had the luxury of moving faster. They can adopt more things. They don't have to worry about, in most cases, don't have to worry about something that was deployed in 1978. Again, it's a physical world of knowing how equipment works and knowing proprietary protocols like Allen Bradley and DF1 and DMP 3.0, which are very niche technologies to be able to understand. So, the way I look at it is, when I started with Coke Oil in 1979, I didn't even know IT existed. Up until working with companies trying to deploy MQTT, setting in meetings where, the OT guys are on the left side of the conference room table and the IT guys are on the right side, and I think they're all trying to say the same things, but the vernaculars just completely mismatch. And I think that's a lot of our, what we're trying to do here in this seminar is get on a common level to where OT can leverage these really cool IT technologies that we should be looking at, but on the other hand, IT understands where the mission criticality, scalability and redundancy of operations really comes into play.
No, that's actually great. I actually think between what Travis said and you said, it really sets the table very well for today's discussion, because we're really talking about these worlds colliding, if you will, hopefully integrated in a smooth fashion, but there are some challenges. This quote from GE's blog, I think, puts it pretty well, where they say, it worked from the top down, deploying and maintaining data-driven infrastructure largely to the management side of the business. OT built from the ground up, starting with machinery, equipment, and assets, and moving up to monitoring and control systems. For a long time, these two divisions kept to their own turf and found their own effective solutions to problems. Then came smart machines, big data, and the industrial internet. And the worlds of IT and OT suddenly collided. I think that blog post called Converge and Conquer, I think, sets the table pretty well too. And it's really true, these disruptive technologies are changing the industrial sector. It's really an inflection point, I think, as Andy Grove once said when he was with Intel, it's a change so fundamental that it basically changes the way we do business. So all of these disruptive technologies, they have something in common. They all increase the amount and the accessibility of data in order to connect people, organizations, and technologies. Manufacturing companies are heading into a world where data is increasingly infused into every aspect of business, and where these smart devices are everywhere and are connecting and they're talking to each other. You have the increase, it's called the 3 V's, the volume, the variety, and velocity of data, where the 3 V's is changing everything. And I think companies are going to continue to say, we got to get to the 4th V. We've got to get to value of data. And they're investing in data like never before. Even major companies like GE and Siemens are leading in what Smart Industry magazine has termed ongoing digitization and datafication of industry. Just one example, consider GE's move. They've made a lot of moves in the last few months and quite a few in the last few years. But one Jeff Immelt did a few years ago when he realized GE could no longer just build big machines. While they would continue to have big iron like the locomotives and jet engines, they also needed to create intelligence within those machines to be able to, collect and parse that data. So when they realized big iron needed to get smart, they made serious commitment to it. They actually invested $1 billion at the time, rebuilding the company's software and analytics approach. They hired software executive, I think Bill Rue from Cisco at the time, set up offices in Silicon Valley, gave him a budget of $1 billion and told him to hire 1,000 software engineers and get busy. And they changed their entire approach as to how they were thinking about the importance and the value of data. And even just one example, this goes across all of their big iron, but if you just take this GE's Evolution Series locomotive, 220 tons, 6.7 miles of wiring, 250 sensors, 9 million data points per hour. And this is an example of basically GE's rolling out a suite of industrial internet tools for freight rail haulers in the U.S. that will improve efficiency. Take the average speed of a freight hauler locomotive, which is 25 miles an hour, and that's not because it can't go faster, it's because they can't get all the logistics, the data, and the information there to have it safely able to move faster. So you think about that and what GE's Immelt calls the incredible power of incrementalization, where incrementally you get benefit and it starts adding up to huge, huge changes from utilizing that data. So if you could have software could increase the average velocity of a locomotive by 15 or 20%, that's just tens of millions of dollars in fuel costs alone. And GE sees these efforts, predicting $2.8 billion in annual savings to their customers. And the 1% improvement, just 1% across all of the activities like that, it adds up to productivity in the hundreds of billions of dollars. So we're talking about a serious shift in the way business is done. Gartner's put a lot more focus on it recently, and it's not just GE. Many organizations are moving in a similar direction. In fact, this new survey by Gartner finds that the number of organizations adopting IoT will reach 43% overall this year, and that includes large numbers of industrial organizations. So when you think about manufacturers and industrial organizations, the worlds of OT and IT are intersecting like the overlapping section of a Venn diagram, if you will, within the larger phenomenon of the IIoT world. So industrial organizations, they gotta shift. They gotta have new ways of thinking. Keeping OT and IT separate is old Industry 3.0 or pre-IIoT mindset. In the world of IIoT and the world of Industry 4.0, we got to work on aligning or integrating the OT and IT sides of the enterprise so we can not only get at the data, the real-time data, the plant floor and field data, but we also can do something with it. Gartner defines it this way. They say they've researched the convergence of OT and IT, done it for years, and they define it as the end state sought by organizations, most commonly asset-intensive organizations, where instead of a separation of IT and OT as technology areas with different areas of authority and responsibility, there is integrated process and information flow. So there's a lot of benefits, tons of benefits. One of the biggest benefits is that you can get more and better information for better decision making. If OT isn't connected to the IT network, then the other parts of the enterprise, they just miss out on this useful real-time data and operational intelligence. In fact, many companies leave 80% or more of their operational data stuck in field devices. There's other benefits that go right along with it: reduce costs, lower risks, optimizing business process, saving time to shorter timelines, for your project development and integration. There's a lot that allows the enterprise to standardize their communication and controls when you bring OT and IT together. Arlen, you've talked about this in relationship to this 80% or more of data that's getting left in the field. Could you make just some comments on this, the benefits that can come and the change that will occur in organizations with an OT-IT convergence?
Sure, Don. I like the example of the locomotive. I was just sitting here thinking, although that's impressive, think of some of the larger SCADA systems, say Fortune 100 oil and gas pipelines. Those are 12, 13,000 miles of pipeline with 2 to 3,000 PLCs. So instead of 6 miles of wiring, you have tens of thousands of miles of wiring and thousands of devices. And typically what I see when we go out and do due diligence with customers is that right now, from an operational standpoint, they're just reaching that what I call tier 1 data. That data that their SCADA system has to have to properly and safely operate the system that they're monitoring. But there's all of this other intelligence out in the field, and to your point of the 80% is that we're starting to look at some of the smart transmitters that are already out there. They're already deployed. Most of them use HARP protocol, but being able to effectively put together a solution that feeds all of the real-time data that we need into the operation side of the business, but also allows some of the other information, like when was the transmitter last calibrated. The operation shows that the transmitter has a fault, so what other information can we get, maybe to cut down on windshield time of driving out there when it could be fixed locally. There's other things, for example, the real-time flow rate from a flow computer is valuable from an operation standpoint, but if I look at it from a line of business standpoint, wouldn't it be cool to be able to get the audit trails, the in-to-batch tickets, the delivery tickets from this intelligence that's already out in the field? So I think, this isn't new. We're going out, it's not like we're asking customers to re-equip their SCADA systems. It's really putting together an infrastructure where we can bring in more data that the line of business can access without impacting the SCADA system. So what we're talking about here is, instead of taking a SCADA system and trying to make it a really bad message-oriented middleware component, let's just go ahead and adopt the fact that we really should be using message-oriented middleware-based SCADA, and then let the SCADA clients be very valuable, but yet not the only data consumer.
I totally got that. I think that when you start thinking differently about it, it opens the whole world of ways to get information into the hands of the people that need it, wherever they be in the organization. Travis, you come with a lot of IT background. You've now taken that and a lot of field experience. Can you make a comment on just your experience of what happens and the benefits that come when you actually do begin to bring together and converge OT and IT parts of an organization?
Yeah, there's two things that I'll talk about here. The first is being able to leverage technologies and data on both sides. So the OT, the operations, has a lot of data, has a lot of information that is important and vital to the business, and IT as well has information that would be really important for the OT layer to have, such as information from ERP systems or front office type systems. So being able to leverage those and be able to connect to those together. So if your OT and IT can work together and can integrate these systems, you get a lot more value out of the overall system. And if you look at just a lot of mission critical systems on the OT side, IT has technologies that can help as far as virtualization and clustering and just with the physical infrastructure to help them with that, rather than having a desktop or a server on the plant floor that nobody sees and is not supported and it dies, nobody knows what to do with, especially from the IT level. Really anything you purchase on the OT side should go through IT, so that there's a management there. They can help with managing it, backing it up, all that good stuff. So not just a real simple, big benefit there. Just have them understand each other allows them to leverage both sides. And when you really connect, when you integrate all the systems together, like Arlen was saying with message middleware type systems, you can get data into more applications, more line of business applications. You get data in more people's hands, and rather than thinking of these as siloed different things, you now have a completely connected enterprise. And there's I can't tell you about the amount of value you can get out of something like that. And one more thing to mention, that just on on the OT side, it sometimes can they usually have completely dedicated networks, and that landscape is changing because data needs to go up into the IT or the information level, and so they can't just have isolated networks. Now you've got to have security. You have to think about security. You have to think about how we can move that data around and all of that. And there are IT has a lot of these technologies, and with middleware, it really helps with this as well. So we'll see more of that here today, but that's the biggest benefit. I mean, you see other benefits here, but it's the landscape's changing. More data we get, and the more that enterprises have to be connected, the more that you cannot have these separations.
Sure. It just isn't practical. I'm going to give an example, but then I'm going to ask each of you to maybe give an example of a concrete use case, if you will, where you've seen something of these things: higher quality and quantity of information, better decision making, or just a lowered cost, faster development and integration time. There could be, we have many use cases, but just to set the table here a little bit, example of how benefits of OT-IT alignment could play out in the real world. So in just take an example of water industry, rain forecasts and wastewater network design information, which is IT. It could be used with current network status as reported by SCADA and other sensors, which is OT. And then you optimize the settings on the pumps and the valves, which is IT and OT together. And you minimize the impact of rain on the wastewater network, such as preventing combined sewer overflows. So I guess maybe I'll start with you, Travis, and see if you could just share a use case or something you did with a customer that shows a little of this benefit and the customer really saw value from this bringing together.
I think the example I'll give, I won't name any actual names to your customers, but the example I'll give is really the combining of data. It talks about how systems are integrated and how if you can add context to your data, now that rapidly turns this raw data into actual information that we can make decisions on. And so in my example of a manufacturing in a production line where we're actually producing, we're getting product, we're making cases of product. In that case, if you look at weather, potentially season of the year, you bring in things like who's the operator as well as supervisors. You bring in information from other systems like ERP, and the more, and there's also labor. Like maybe in this case it was Kronos, bringing in who was on the line, who was in there. You start looking at the production line as more than just as was I running or not, is machine on or off, or what's the temperature or whatever, into how does this translate into actual money. Right. And you can get into your example of 1% improvement. And in this case, you find this data and you start correlating together, and it actually amounted to pallets and of product over just a course of 1 week, which by just improving by 1%, the amount of savings and things that customers get is huge. And that just goes into having all the systems work together rather than trying to make it completely isolated.
Sure. Arlen, how about some use case or example from you of one of these benefits?
Okay, Don. Well, I guess I'll start with the actual kind of genesis of why we put MQTT together, the opportunity that was there to actually work with Andy Stanford Clark at IBM on this. It actually was for a project for Phillips 66, and they wanted to get, there were several goals there. One was to reduce latency from 1 minute to 45 seconds down to getting all of their operational data in under 10 seconds from their entire pipeline. But then kind of the tangent to that was, like I was saying before, their flow computers were connected to the network. They were bringing in the real-time flow rates. They wanted to get their financial transactions once a batch of oil was delivered from the 30 days, which was typical, down to under 15 seconds. And so by putting this together, that was actually a very good example where IT and their electronic flow measurements group worked with OT to say, look, we have all this equipment out there. operations definitely needs this subset of information from the flow computers. The financial department needs this other subset. So why don't we just publish all of the information in, and then the valuable data consumers can subscribe to that. Again, a one-to-many data relationship. And so where OT and IT came together was mapping out the available data that they had, and then being able to route that to the right places. And I'm seeing that again in things like monitoring their cathodic protection systems, their tank storage systems, where we can actually reach behind the PLC and start picking up some intelligence from the tank transmitters that tell us the actual volume. So now I can start putting together very interesting over and short projects that tell me my total volume balance of a pipeline of an overall system. So it's almost like, again, when you think of PLCs, RTUs, flow computers, chromatographs, barcode readers, all of these devices intimately connected to a SCADA application, then innovation is very slow, because you've got to go talk to that operations manager that says, gee, Joe, I would like to add a couple more poles to your Modbus pole because I need your application to get this piece of data. Whereas, if you want to, I call it the serendipitous nature of data, where I should be able to have an idea, within permissions and bounds of safety, but I should be able to have an idea, be able to go in and put together an application to try an idea in a line of business that might improve profitability. And with the architecture that we're talking about, I can come in, subscribe to a subset of data, try something. I haven't impacted the critical nature of operations. And, oh, well, it didn't work, so I just spin out my subscription and, no harm done. But on the other hand, it lets me go in and say, well, wow, this is a valuable relationship of this data, and we're going to see some of those benefits that you pointed out, Don, that GE's seeing.
Sure. That's great. Thanks, Arlen. I appreciate you, both of you guys, expounding a little bit on there's amazing benefit to be had here. Travis, you mentioned in passing the changes that come when you bring networks together, one of them being security as an issue. There are a lot of challenges, and the biggest may be the security one to some people. Reality is that when you start having proliferation of these sensors and other smart connected devices, it's brought along with it an increase in security vulnerabilities. So OT and IT have historically had differing security needs, though they've become more similar, obviously, as time's gone on. OT systems have used proprietary technologies that made them less likely targets for attacks, maybe security by obscurity or whatever it's called. OT systems have also been fairly self-contained with few connections to other systems. On the other hand, IT and enterprise systems, frequently under attack, have a higher level of acceptable security risk because IT usually has a higher tolerance for downtime than OT. So comments, maybe first you, Arlen, and then Travis, on just security challenges as we begin to bridge OT and IT across the enterprise.
Okay, Don. Well, again, let's look at a little bit of the history here. If I look at SCADA or telemetry from a historical point of view in the late 70s, early 80s, basically the world all ran on multi-drop phone lines from AT&T. If we had a 300 baud or a 1200 baud modem, we could hang that onto our 4-wire dedicated circuit, and we could start putting together our SCADA system. Then, in the mid-90s, the breakup of AT&T, the proliferation of VSAT, people starting to put in their own microwave, and now, to where we're at today with basically, even though we're trying to encapsulate old polling protocols, we're all running TCP/IP networks. I know very, very few companies that aren't running their SCADA system on a TCP/IP network, albeit with all kinds of adapters and terminal servers and protocol translation. So, let's just kind of put it out there that, we are all on TCP/IP networks. So the challenges are, how do we actually say, okay, now we're going to bring in some mature and call it OT or IT technologies to add to the level of security that we need. Now, if we talk about it in terms of leveraging messaging middleware, one of the things that MQTT does is really does a 180 on just the connectivity, because MQTT clients are a remote originated connection. So if you can imagine, now instead of having hundreds of connections out of your SCADA host through all kinds of firewall rules and over all kinds of networks, now your SCADA host becomes very quiescent and basically sits within the DMZ, where you have a single point of control for all access on devices connecting and publishing your data. So I think, as we move forward, as we start getting the technology and the edge of network devices and the native devices using MQTT, security will become much easier to accomplish over the entire network.
That's great. Thanks, Arlen. Travis, your thoughts on the security world?
Yeah, I got a couple things I can mention on this front. I think Arlen's mentioning how middleware can help flip the picture around as far as SCADA, pushing data up rather than having systems connect and pull and having to open up ports and things in the firewalls. I think it's important that both sides really especially IoT, have to understand what the landscape is, what PLCs are doing, and how they're mostly open. There's not really security in there. How we really have to make that part protected. But we still want to that data has to be moved around. We still want to get that the value of that data. So like Arlen was saying, middleware really helps transport that information around. So I think understanding it is really key, so that we can do the right things. And I think also leveraging IT systems like Active Directory or just firewalls in general, potentially leveraging cloud systems securely, VPNs and all that are really important, because now it's not just that one panel view that's next to the machine on the plant floor that's controlling it. Now somebody at home on their smartphone or over a VPN connection can be looking at it. So you've got to have a system where I think the biggest challenge is what kind of privileges are you going to allow people to do from different parts of the world when you have the valid the ability to connect up to it. I also think that we're going to start seeing leveraging smart cards and certificates and things where you actually have to have two phases, a smart card and a PIN, to be able to access systems, so that gives even a higher level of security there. So I think there's a lot of things to look at. There's some challenges, but understanding it and being able to put the appropriate infrastructure in place to handle it is really key.
Thanks, Travis and Arlen. Let's just take a look, at least briefly, at a couple other challenges, because you hear different things about the evolution of OT/IT. One is the demand, obviously, for ROI. A newer Gartner survey cited earlier also says, quote, "The big challenge now is demonstrating return on investment. Executives need to validate the contribution that IoT can make in order to justify large-scale rollouts." Then, of course, there's the fact that edge and network devices tend to use different protocols for sending and receiving data, and the subject of the overall issue of interoperability, and how do we make all these different kinds of devices all connect to each other. So I know we'll dig in a little deeper when we talk about MQTT in a minute here, but if you could just maybe comment, Travis first and then Arlen, on the challenges, from ROI and different protocols and interoperability that are faced when you're bringing these together and executives are scrutinizing some significant rollouts. Arlen, you want to go ahead and comment on that?
Well, first of all, Don, every single customer that we have are wanting to get to a common infrastructure. You can call it what you want. Call it, SOA, service-oriented architecture, or enterprise service bus, ESB. But again, we're going back to this notion of this legacy of, yes, we have MQTT, we have some other competing IoT technologies, but man, if you jump into the SCADA world, there are hundreds of proprietary protocols. I enjoy we use Modbus. Well, which one of the 14 flavors of Modbus do you use? So, being able to compartmentalize this and get to a common message transport layer, I think is the key thing here, even to the point of, even if operations don't want to work with IT at the beginning, and a lot of times I understand that, but at least we're putting in place the tools so that migration can start happening, and we can start that integration process.
Great, thanks, Alan. I appreciate that. Let's move on and take a look at just a little bit more on the case for the ground up, building from the ground up. It's in the title of today's webinar. There's a lot of alliances, there's a lot of consortia. They've put forth the notion that IoT should be, a lot of them are just building from the top down, IT-driven methodologies. The so-called experts, if you will, may have it backwards. I mean, SCADA's already been doing IoT for years, before there was even a term called IoT. So about 30 years now, industries like whatever, you mentioned a couple, in the oil and gas world, chemicals, pharmaceuticals, manufacturing overall, they've been using sensors to improve their processes. Those industries capture huge amounts of data from PLCs and pass them to SCADA systems, as real-time data, which is displayed and stored. Basically, they're integrating large amounts of data to enable better decision-making. If that's not what IoT is about, I don't know what it is. It's what it's about. From the perspective of IoT, it isn't so much a new thing as it is really a redefinition of what operations people are already doing and extending that out to the enterprise. That makes a strong case that OT should drive the implementation of IoT, and not do it the other way around. So I think there's a lot of players out in the space today and people who don't necessarily understand the operational side. And by trying to implement IoT without first understanding OT, it's kind of like not knowing what you don't know. If you try to put out, so IT-centered top-down solutions, they aren't amenable to teams that work on the plant floor or out in the field. It's just not going to work. So if you're going to make IoT work in an industrial environment, really, it seems there's only one way to do it, and that's build it from the plant floor level, from the field level up. Arlen, you may have covered this quite a bit, but anything you want to comment on? It's why it's so important for IoT solutions to work in the field and plant floor and move up through the enterprise.
Well, Don, like I said, for the 17 years that I've been trying to get this technology out into the world, again, I guess my mistake, a lot of times I was looking at it as IT driven. And we got so wrapped around the axle from an IT perspective of implementation, we forgot, what the goal was. There's not one project that I've gone into where if you can't prove to the SCADA manager, to the operations manager, to the plant manager that what you're putting in place isn't better from a safety critical, redundancy, availability, scalability than what he's got today, then he can stop that project dead in its tracks. So from my standpoint now, the way I look at it is you've got to show, for whatever your IIoT solution is, you've got to show operational excellence before you can move forward and go to the enterprise level of actually integrating IT and OT together.
Thanks, Arlen. I think it really is. It's emphasized here that you got to move from the knowledge of the plant floor up if you're going to connect the enterprise and end up making better decisions. So, I mean, in essence, what's needed is practical, fully functional IoT solutions that actually combine those proven operation technologies with the information technologies, and that's the way to bridge this sort of long-standing gap between IT and the OT sides of the house. And that actually is what Ignition does. It's all about Ignition's IoT solution. It's quite different from other solutions that are so far been talked about or offered so far. Ignition really has been, since its inception, at the epicenter of IoT, and that's before that was even a term. I mean, that was the concept that our CEO and founder, Steve Heckman, had, was to build this hub, if you will, this applications platform that would save exponential amounts of time and would actually allow you to decouple intelligent device protocols from applications in order to make data available throughout the whole enterprise. So we built it from the ground up, from the OT level, connecting up to the IT level. In addition to that, just a couple other points. It has all these other features that make it really effective as a universal industrial automation platform from HMI, SCADA, IIoT, MES across the boards. Already mentioned these features at different times. So Travis, as someone who's worked on countless projects in renewable industries, I think you're the best person to actually answer really is why is the Ignition Industrial Application Platform positioned as the standard platform, or as the hub, if you will, for the evolution of IIoT?
Oh, that's a great question. And Ignition is just perfectly suited for this because of the marriage of IT and OT that we've had from the beginning. So if you really look at, inductive automation's, Ignition product, it was a culmination of an integration company who had 25 years of experience with IT professionals like myself, adding our expertise into it, and how we can marriage, put the two together in such a way that's going to leverage, both sides. And that was just making it standardized, and obviously using standards like OPC and others are really important to allow it to talk to a lot of different things. But working with just natural databases, keeping things open, not proprietary, and having it be server-based, where it's one place to manage and back up and license, and easy to get people, for deployment, easy to develop and deploy applications extremely fast. I think that is one really big part that can't be understated when you look at companies, especially now with IoT, where things have to change very quickly. And when you have things that need to change quickly, you've got to be able to have a platform where you can make the change and to be able to deploy that change and not have to rely on a huge, rollout or personnel to do this. The other thing is we look at the amount of data is going to increase, and we'll talk more here, but with MQTT and middleware, that enables Ignition to auto-discover all the information that just starts popping into the network. And so when you auto-discover that, and then you can actually deploy that information to people and start turning that raw data into information, now we can start making decisions. So Ignition's, its philosophy of being, server-based standards, simple licensing, unlimited, and be able to be scalable is really what allows it to play very nicely in this space.
Thanks, Travis. I think you covered it really well. It was created to be able to bridge this gap between OT and IT. But let's move on to the next question, which is what protocol to use. There's a number of different communications protocols clearly out there and currently in use. The message queuing telemetry transport, or MQTT transfer protocol, it's pretty quickly emerging as the standard for IIoT. It's becoming a dominant thing. It's developed for oil and gas, as Arlen talked about as a co-inventor of it. Is in 1999, and it quickly risen to become one of the most dominant messaging transports for IoT. Its use has spread, of course, beyond those beginnings. It's used in Facebook Messenger and Amazon, I think with Echo. You're seeing it in a lot of different places. MQTT is now an ISO standard and an OASIS standard. So as you look at this publish and subscribe protocol, that's a really important aspect of MQTT. When you have legacy protocols and they're used, about 80% of that valuable data just gets left behind in field devices. And even though that data could be used by business applications to make a whole lot of better decisions, it's not available. So because the Ignition IoT solution uses MQTT, it can decouple intelligent devices from the applications. So it ends up creating this single, super efficient data pipeline through which data is pushed from thousands of devices into a central location where it can be accessed by your industrial and business applications as they need it. MQTT has several features that make it really effective for remote sensing and control IT reports by exception, and all sorts of big benefits. But I think it's, and when I think about this, Arlen, here's some things about it, the stateful awareness, but you're a co-inventor of it, so why don't I turn it over to you? Sort of when you put stateful awareness, bidirectional ability, and security into MQTT, tell us a little bit how it ties in with what's going on right now and bring us up to current as to why it's a really correct protocol for IIoT evolution.
Okay, Don, I'll try to be real quick here and hit the high points. again, the advantage we had is we had 25 years of doing protocol conversion and SCADA infrastructure that literally got kind of packed into MQTT. At the same time, Andy and the IBM team had all this knowledge of messaging middleware and why do you use it. And I think the one thing I want to point out is that, yes, it's very lightweight. I noted before it runs quite well on 300 baud circuits. But the most thing is that we understood that if you don't have state, and people forget about this because they look at message-oriented middleware and they say, oh, well, that's publish and subscribe. I'll just publish my data and then I'll publish a valve open. But you cannot do that in SCADA unless you have a stateful session. And so one of the very unique things to take away from this discussion is that MQTT, when applied to SCADA, works on the notion of having a stateful MQTT session, i.e., if I look at a pipeline system and it's got 1,400 MQTT clients publishing real-time information, I know within the keep alive time of the state of all 1,400 of those clients in real time. And so that gives me that hook that I need when I actually apply MQTT to real-time SCADA systems. Again, there's other aspects of security since it's built on top of TCP/IP that's also very important as well. But the best thing is the fact that it's got state, the fact that it's super efficient, and the fact that it's running on top of TCP/IP.
Arlen, thank you very much. I'm going to interject a question from our audience now. I know we're moving towards the end here, and I want to get into our Q&A, but I'm going to interject one right now from a member who says, are you seeing protocols other than MQTT playing on this OT-IT convergence? Is DDS, SCOAP, RESTful/HTTP, etc., players on this world? Are there other players? Can you maybe just give a brief comment on some of the other protocols and how you see that playing?
Well, indeed, you brought up a lot of them there. I think when you look at REST or HTTP, those play very well into this overall notion, I guess, of IoT. The problem, though, when we try to apply HTTP or REST or CoAP even into SCADA, none of those protocols really give you state. So if I told a SCADA engineer that I was going to control his 5,000 horse motor with HTTP, but I really didn't have state, I would just kind of send something out there and it may start or it may not. Either I'm going to spend a lot of time polling, which now that doesn't do any good, or I have something like MQTT that gives me state. There are other protocols like DDS, AMQP. Those tend to be heavier on the wire. They have additional levels of quality of service that work well in IT, but really don't work so well in, well, at least wide area SCADA, because you have networks that come and go, so you have to have something that's very lightweight and usable on VSAT or cellular networks.
Thanks, I really appreciate that. Thanks, Arlen, for that. I'm gonna say a couple more things about MQTT, and then I'm gonna let you talk a little bit about the modules and the functionality that you're bringing together with that. In our discussions earlier, just as a passing point here, the graying of technology, the retirement of the baby boomers, if you will. There's engineers with deep knowledge of legacy technologies, but they also happen to be retiring, and there's a new generation of engineers coming out who have who really understand more the technologies like JavaScript and Python and MQTT. So I think you have to look at this in the context also is what's happening to the workforce and what evolution is going to occur in industry in that capacity. And just an emphasis here, decoupling device protocols from applications is a critical component. When it enables use of message-oriented middleware, which Arlen has talked about, those technologies that decouple device protocols from applications and allow you to subscribe to the data you want, and it's published by exception, so it's a more efficient information distribution, and it has amazing scalability and much shorter, much shorter development times. And also decoupling this, it brings in much more data more quickly. Projects can be done in days or weeks instead of months or years. And maybe you can just make a quick comment on this last bullet point here, because you gave an example of a 3-month timeline that came down to get the entire infrastructure running in a day. Can you comment on that, Arlen?
Well, yes, Don, real quick. Again, we since this is convergence, we tended to get wrapped up in the complexities of putting in these message-oriented middleware systems and what was my enterprise service bus definition going to be and all my data templates, when, let's look at that from an operational MQTT enablement. And so now with the components that we've got within Ignition, with distributor, injector, and MQTT engine, we were putting together a proof of infrastructure for a customer where if they would have looked at an on-premise, set everything up, it was looking like a lot more than 3 man-months. It was looking like in man-years. They wanted to get an infrastructure up to test with, called us 8 o'clock in the morning, said we're ready to get going. We spun up the entire infrastructure and had the entire pipeline simulated with more than 900 booster stations, 1,400 PLCs by 2 o'clock that afternoon.
So I moved to the next slide here because you talked about these. Can you briefly then say there's 3 new modules you created for Ignition and the empowerment that they're causing, and then we're going to move into a little bit of Q&A because we got a whole stream of questions here we want to use our remaining time. But give us the definition of these.
Okay, real quick. MQTT engine is the core component. That's the MQTT client that makes Ignition a native MQTT citizen. So it knows about the topic namespace. It knows about this MQTT session, the session awareness that I talked about a while ago, where you have state. So that's what it does on the MQTT side, connecting into your messaging middleware. On the Ignition side, it also knows about all of Ignition, how the tags work, how the history works. And so the engine module is kind of that core piece that once you install that into Ignition, that's your MQTT bridge, if you will. Then what we discovered is that we needed to make this easy. So the MQTT distributor module is actually a MQTT compliant MQTT server that actually a very small one. It is limited to 50 clients, but it runs as a module in Ignition, so you can get started very, very quickly. And then the other thing that we found out is Injector was originally a simulator that would simulate many, hundreds or thousands of PLCs to basically see how this thing works. But what we found out, it was actually became a very important design validation tool as well as people started putting together these MQTT-centric systems. So you've got the engine module, which enables Ignition. You've got the distributor, which gives you a small MQTT server to get started with, and you've got the injector to build up full-blown simulations of what you're trying to put together.
Thanks. I totally appreciate you giving a quick summary of that. And I'll just say, as we wrap up and move to Q&A, I mean, this came up. If you didn't get a chance to watch the release of those modules last month, it's archived on our site. You can see, I think it was 1,000 PCs that you spun up there using the injector. I mean, it's an amazing demo. Many people who are on this webinar wanted us to go deeper into some of what is the whole evolution going on here. But that demo is still available on our site. I think that the takeaway I'd like to leave you with is that Ignition IIoT empowers your enterprise to realize the full power of your data, and it's operational today. It's built on the power of the industrial application platform of Ignition, and unlimited licensing, unlimited possibilities. The unlimited nature makes it possible to actually scale without squelching the innovation that you're trying to come up with. Streamlines the data pipeline, increases data availability, improves throughput, and instantly creates tags, as Travis was talking about too. It fills that fundamental need that we're trying to get at with IoT to access more data in order to make better decisions. If you want to learn more, just go to our site and you can log on there to inductiveautomation.com and click Ignition IIoT. So as we move into the Q&A with the few minutes we can still have left here, I think let me just ask the first question here for Arlen. What if I want to combine a client server, say HTTP, and a publish subscribe protocol such as MQTT? Will Ignition support that type of architecture? Edward has this question.
I believe so. Actually, Travis might be able to comment on that better than I can. But since the tags are coming in MQTT, once they're in Ignition, then you've got all of the web services availability to be able to use REST or HTTP to access those tags once they've been put into Ignition.
Yeah, and to expand on that, certainly MQTT will be the driver to get the data into Ignition. And then as far as Ignition's, it's client server based. The clients are web launched. You just run them anywhere in your network, and they can see all that information, on the screens that you develop in it. So that HTTP is fundamental, and HTTPS is fundamental to Ignition, and MQTT enables the actual data.
Great, thanks, Travis. Any thoughts? Is this one for, okay? Any thoughts about Exxon's initiative to standardize standardized process control hardware and move away from proprietary solutions? I know this was released in their work they're doing with Lockheed Martin at the ARC conference. You were there, we were there last month. So comments on that, Arlen?
That's been put out there. We've got, I know that there's a company, we're working with Magnetrol that makes smart heart transmitters. They're using MQTT edge of network devices to bring that data in. I know Exxon was very interested in that. I think there's a lot of availability here, and I just want to mention that one of the driving factors is that with all of the open source and information that's out there on MQTT. So if you go to the Eclipse Foundation and look, or you Google for the PAHO project, you'll see that there is a ton of information out there on MQTT. One of the points that I wanted to make that I'll make real quick is Don mentioned the graying of technology. And I just got to thinking that if you look at the graduating class of computer science majors in 2016, you get them all in a room, ask them how many are intimately familiar with Modbus or Allen Bradley or OPC UA. But then ask them how many of them in their dorm room have Mosquito running on their Raspberry Pi. And it's just that awareness of this technology, and we as an industry should try to figure out how to leverage that.
Arlen, I think because we ran over our time a little bit, I think that answer is a good place for us to end off. But I want to say well, first, thanks to you and thanks to Travis for taking time to just engage in this discussion today. And to all of our audience, we have a queue of questions, and so I'm certainly volunteering time from Arlen and Travis. We will get an answer to those questions that you had, as we always do, because we couldn't get to all of them today. But I thank you for your interest in joining today. I think this evolution to IIoT and the convergence of OT and IT is really critical to industry right now, and one that we're going to continue to try and bring solutions to. If you haven't seen the release of the modules from SiriusLink Solutions, you can go to our site and participate in the February 24th webinar that's archived there and listen to it. With that, we're at the conclusion of today. Thanks everyone for your time, and have a great day.